Welcome to Six Sigma Online Certifications. We are on the topic Six Sigma Fundamentals, Quality Tools, Part 7. In this video, we will learn about how to make histogram, how to interpret histogram, and also how to use a statistical tool called Minitab for making histograms and interpreting it. So, how to plot a histogram manually? A histogram is a graphical representation where y-axis is the frequency of the data, whereas x-axis is the parameter. For example, in this case, length. So first we are going to identify how many data points are there. Then we'll compute range by max minus minimum. Then we will determine number of class intervals. Then we'll compute the width of the class interval. And then we determine the class intervals. Then count number of data points in each class interval and then plot the histogram. So let us understand this one by one. First, count the number of data points. Just multiply rows by column, normal mathematics, and there are total 60 data points given to us. Then we'll compute range. We'll see the data. We found that 7 is the maximum value, minus 2 is the minimum value, and therefore the range is 7 minus 2, and therefore the range is 9. Third step is determine class interval. While the class intervals can be determined statistically based on the data, we can use this table for manual calculation. Since our data points are 60, our class interval should be between 6 and 10. Since our range is 9, we'll suggest we also take class interval as 9. Therefore, number of class intervals is 9 so that we get a right class interval for calculation. So how do you calculate class interval width? You just divide range by number of class intervals. So we chose 9 class intervals, so 9 by 9 becomes 1. The fifth step is determine class intervals. So we always start from the minimum value and keep on adding the class intervals width which we have chosen. And after the maximum value is reached, we add one more, because the rule of histogram is the class interval includes the lower value but does not include the higher value. Then we count number of data points in each class interval using tally marks, and then plot this class interval on x-axis and the frequency on y-axis. This is called histogram. This is how we make histogram manually. Now let us learn how to interpret histograms. The interpretation of histogram includes the center of the data, spread of the data, the skewness of the data, it is biased on any side, the presence of outliers, and also relative to specification. So these are the ways we can analyze histogram. So let us understand how to visualize and understand few of them. So we have this data which indicates the peak or most of the data is accumulating towards 45 and rest of the data is equally distributed around 45. So age is 45. And some people are very old. You can see two of them are more than 60, which indicates there are some outliers. And there seems to be no bias. The organization doesn't seem to hire very low age or very high age people. It is normally distributed. The second graph shows the histogram for profit. We can see the average profit is around 1050. Sometimes one incidence we have loss more than minus 250, and bias is for increasing profit. We can see the data is skewed on left side, so entire data is coming on the right side, and this clearly indicates that there is a clear directive of increasing profits, which should be the case B. In this case, we can see two peaks, and when we see two peaks, they're likely the data is mixed and we have two means, 48 and 65. Such data which has multiple peaks is called as bi-modal data. And if there are more than two peaks, we call it multimodal data. In this case, which is reaction time, we can see the slope of the histogram on both the sides is different, which indicates while the average is 23, bias for reducing reaction time is being resisted by different slope on other side. So bias is there but not clearly biased on one side. In this graph, we can also see that we are comparing the data with respect to specification. Any values less than LSL shown by red lines indicates defective. Same way, anything more than USL indicates defective shown by red lines. To interpret it easily and faster, we recommend use of Minitab. So we should open this file understandshapes.mtw to understand how to make histograms faster. So we have data called ball dia, cost, age, profit. We'll just directly go to graph, go to histogram. We'll keep it simple and go to OK, and then choose ball dia. Click OK. The histogram is ready. Show graph folder. So if we click on highest tallest bar, we can see this is the class interval is between 12.5 and 12.7 and the frequency is 88. I'll just request you to click on Ctrl E, choose everything from cost to reaction time and just go and select. You can make all the histograms together. So all the histograms will appear together, and we can see that if we want to go to cost, or we want to go to age, or we want to go to profit, we can see any of the graphs in one incidence. Thank you so much. For testing your knowledge on this video or for Six Sigma certifications, visit leandigit.com. For more knowledge on this topic, please subscribe our channel.